On the evening of May 20th, 2024, something happened beneath the streets of Pozzuoli, Italy, that had never been recorded before in 40 years of continuous seismic monitoring. At exactly 7:51 p.m. local time, the ground began to shake, not with one earthquake. Not with 10, but with 150 separate earthquakes erupting from the earth in just 5 hours. Families rushed into the streets. Children screamed. Car alarms blared across the ancient port town. And then, at 8:10 p.m., the strongest earthquake ever recorded at Campi Flegrei in the modern era struck with a magnitude of 4.4 and at just 2.5 kilometers beneath the Solfatara crater. The prison walls cracked. 39 families were forced to evacuate their homes that very night. This was not a random natural disaster. This was something scientists had been quietly dreading. A new type of seismic behavior that had only been seen once before in history, right before another volcano violently exploded. But here is what makes this story absolutely terrifying. The May 20th swarm was not an isolated event. It was part of an accelerating pattern that scientists at Italy's National Institute of Geophysics and Volcanology had been tracking since early 2021. They discovered that Campi Flegrei, the massive volcanic caldera that stretches beneath Naples and threatens 500,000 residents, has developed a completely new earthquake signature. These are not your typical volcanic earthquakes. Scientists call them burst-like swarms. They happen so rapidly, sometimes just seconds apart, that monitoring equipment can barely distinguish one quake from the next. The seismographs show what looks like continuous shaking, a pseudo-tremor that suggests the Earth itself is failing continuously beneath the city. Between 2021 and 2024, over 18,500 earthquakes were recorded in this region. The vast majority were too small to feel, but the pattern has been unmistakable. The intervals between earthquakes have been shrinking, the magnitudes have been climbing, and the location of these burst-like swarms points directly to the heart of the caldera's hydrothermal system, where superheated water and volcanic gases are building pressure at depths between 2 and 4 kilometers. On April 14th, 2024, scientists recorded a burst-like swarm of 36 distinguishable earthquakes in rapid succession, peaking at magnitude 3.7. The background seismic signal never stopped. On July 26th, another swarm struck with 6 earthquakes, the largest reaching magnitude 4.0. Each time, the pattern repeated. Rapid-fire earthquakes clustered in the exact same area near Mount Olibano and the Solfatara Picierelli hydrothermal field. Each time, the ground continued to rise. Right now, the caldera is lifting at a rate of 2 centimeters per month. Since 2005, the ground has risen 130 centimeters, surpassing even the terrifying uplift rates seen during the 1980s crisis, when over 40,000 people were evacuated from Pozzuoli. But there is something even more disturbing that scientists discovered in a study published in Nature Communications in February 2025. This exact type of earthquake pattern, these burst-like swarms with inter-event times measured in seconds, has appeared before at other volcanoes around the world. At Hakone volcano in Japan, burst-like swarms preceded a phreatic eruption in 2015. At White Island in New Zealand, the same pattern appeared within the volcano hydrothermal system before explosive activity. At Tatun volcano group in Taiwan, scientists interpreted burst-like swarms as the brittle response to rapid fluid pressure changes in fractured rock. Every single time this pattern has been observed, it has signaled one thing: the volcano's hydrothermal system is approaching a critical threshold. So what exactly is causing these burst-like swarms to concentrate in one specific area? Scientists discovered something extraordinary when they analyzed satellite radar data from Sentinel-1 and Cosmos SkyMed between 2021 and 2023. While the entire caldera has been rising steadily, with the central area uplifting 120 centimeters since 2005, one particular zone is behaving completely differently. This is the Mount Olibano area, located just east of Pozzuoli town, covering approximately 1.3 square kilometers. And here is what makes it terrifying. This zone is rising 9 centimeters less than the surrounding areas. Think about that for a moment. 2. The entire caldera is being pushed upward by massive pressure from below. But this one specific area is resisting, lagging behind, refusing to rise at the same rate as everything around it. Why does this matter? Because this anomaly appeared at exactly the same time as the burst-like swarms began in early 2021. The correlation is undeniable. Scientists analyzed the timeline and found that the evolution of this uplift deficit tracks perfectly with earthquake occurrence. The largest magnitude events are clustering directly in this anomalous zone. Francesco Cajo, Research Director at Italy's National Research Council, Institute for Electromagnetic Sensing of the Environment, explained that this anomaly manifests as a region rising less rapidly than surrounding area, suggesting complex dynamics linked to the interaction between ground deformation, seismicity, and hydrothermal activity. But there is more. This geodetic anomaly sits directly on top of the most dangerous part of the entire caldera, the Solfatara Picierelli hydrothermal system. Between 2021 and 2024, carbon dioxide emissions from this system skyrocketed to 1,557 tons per day in 2024. To put that in perspective, that is the same emission rate as an open conduit volcano, a volcano with direct connection between its magma chamber and the surface. The Mount Olibano area contains ancient lava domes with different rock types and structures than the surrounding caldera. These lithological heterogeneities are creating zones of weakness in the crust. As the pressure builds from below, these weak zones are fracturing differently than the rest of the caldera. Scientists believe the slower uplift in this area is because the rock is cracking and allowing hydrothermal fluids to circulate here. Is the question you need to ask yourself. If one area of the caldera is cracking and fragmenting under the stress, while everywhere else is rising uniformly, what happens when those fractures connect? What happens when the pressurized fluids find a pathway to the surface? Have you ever seen what happens when superheated water under pressure suddenly finds an escape route? Write your answer in the comments below. The people of Pozzuoli are living inside a seismic laboratory whether they want to or not. Maria Conte, 62-year-old resident, who has lived near the Rione Terra Historic District for 40 years. School attendance drops every time a significant swarm occurs. Business owners near the port report that tourists are canceling reservations. The ancient Roman market of Rione Terra, painstakingly restored and reopened in 2017 after decades of closure, now sits partially abandoned again. The port of Pozzuoli has experienced repeated disruptions. During the strongest swarms, ferry services to the islands of Procida and Ischia are temporarily suspended as captains assess structural integrity of dock facilities. Buildings constructed before modern seismic codes show visible stress. Cracks appear in masonry walls after each major event. The municipality has conducted over 15 evacuation drills since 2022. Yet a study by the University of Naples Federico II found that 63% of residents surveyed did not know their designated evacuation route. Civil protection authorities upgraded the alert level to yellow in October 2023, but many residents feel the communication has been inadequate. They see the earthquakes increasing. They feel the ground rising beneath their feet, but official messaging remains cautiously optimistic, emphasizing monitoring rather than preparation. Let me explain exactly what is happening beneath Campi Flegrei right now, because understanding this mechanism is critical to understanding why scientists are so concerned. At depths between 3 and 5 kilometers below the surface, these fractures are not releasing pressure uniformly. Instead, they are channeling superheated hydrothermal fluids and volcanic gases upward through preferential pathways, creating zones of concentrated stress. The burst-like swarms are the audible signature of this process. When fluids migrate rapidly through newly opened fractures, the surrounding rock responds by failing catastrophically in rapid succession. The inter-event times of just a few seconds indicate that once fracturing begins in one location, it triggers immediate cascading failure in adjacent rock. This is identical to the mechanism observed before phreatic eruptions at other volcanoes. At Hakon in 2015, burst-like swarms appeared 6 months before a phreatic explosion created a new crater. At Anteg volcano in Japan in 2014, similar rapid earthquake sequences occurred in the weeks before a sudden eruption killed 63 hikers. Now here is what you need to watch for. INV publishes daily bulletins at their website. The key thresholds to monitor are ground uplift rate exceeding 3 centimeters per month, magnitude 4.5 earthquakes occurring within the geodetic anomaly zone, sustained earthquake swarms lasting more than 12 hours with magnitudes consistently above 2.5, carbon dioxide emissions exceeding 2,000 tons per day at Solfatara, and any significant changes in fumarole temperature at monitoring station PZRLE. If 3 or more of these thresholds are crossed simultaneously, the probability of a phreatic explosion within the following weeks increases substantially. This is not fear-mongering. This is pattern recognition based on decades of global volcanic monitoring data. You do if you live in the red zone, the area within 8 kilometers of the caldera center. Prepare a grab bag with essential documents, medications, 3 days of water and non-perishable food, flashlight, battery-powered radio, and cash. Keep it by your front door. The scientific community has given Pozuoli residents something previous generations never had: advanced warning, real-time monitoring, pattern recognition from volcanic systems worldwide. The burst-like swarms are speaking a language that scientists have learned to interpret. The question is whether that warning will be heeded. If this information helped you understand what is really happening at Campi Flegrei, hit that subscribe button right now. The next video will cover the newly discovered volcanotectonic fault that is actively forming beneath the caldera since 2023. This is information that could save lives.